Welcome to the peaceful space of sleep-friendly science, where our journey tonight takes us to the vast, serene emptiness between galaxies, a place of profound and quiet mystery. Have you ever gazed at the night sky and pictured the immense, dark spaces where the stars are not? Tonight, we will gently drift into these great cosmic voids. Let's explore this beautiful, silent puzzle together, wondering why the universe is not evenly filled but instead is a magnificent cosmic web. Now settle in, take a deep breath, and let the soft sounds guide you as we begin tonight's journey into the unknown. Section 1. The Cosmic Tapestry's Grand Design. Let your awareness settle not on the room around you, but on the vast, quiet canvas of your mind. Imagine it as a space of perfect, deep black. And into this space, let us place a single, shimmering point of light. A star. Our sun, perhaps? A familiar, warm beacon in the immense dark. Now, let us gently pull back. See the star joined by its family of planets, spinning in a silent, graceful dance. This is our home, our small, precious corner of the cosmos. But our journey tonight calls for a grander perspective. So, let us continue to drift backwards, a slow and effortless retreat from the familiar. Our solar system shrinks, becoming a tiny mote of dust in a swirling river of light. This river, this majestic, spiraling band of 100 billion suns, is our Milky Way galaxy. From here, you can see its beautiful, luminous arms, like pinwheel streamers thrown across the darkness. It is a city of stars, impossibly vast, humming with the silent energy of creation. Find a comfortable place in your mind to float, to simply observe this island of light. Feel its scale, its grandeur. It seems like everything a universe unto itself. For most of human history, we believed it was. We believed the story ended here, with our magnificent island galaxy, surrounded by an endless, empty ocean. But tonight, we travel further. Let your consciousness continue its slow, backward drift. The Milky Way, our grand home, begins to shrink. It is no longer a sprawling city, but a single glowing jewel. And as you drift further and further, other jewels appear in the velvet black. First one, Andromeda, a sister galaxy, a near twin to our own. Then another and another. Tiny, faint smudges of light at first, like frosted breath on a cold window pane. But as your perspective expands, millions, then billions of times larger than before, you see that these are not random specks. They are not scattered like sand on a beach. A pattern begins to emerge from the darkness, a structure of breathtaking scale and elegance. It is here that the true nature of our universe reveals itself to you. It is not a random collection of things. It is a masterpiece of architecture, a grand design. Imagine a weaver of infinite patience working with thread made of pure light. This is the sight that now unfolds before you. The universe is a cosmic tapestry, a magnificent, intricate web. The galaxies are not islands, but beads of dew clinging to luminous, shimmering threads. These threads, these filaments of light, stretch for hundreds of millions of light years. They are great, glowing rivers of galaxies flowing through the emptiness, connecting and weaving together in a pattern of unimaginable beauty. They twist and turn, braid and converge, creating a structure that is both delicate and immense. Where these threads meet, the light becomes brighter, more concentrated. These are the great crossroads of the cosmos, the superclusters of galaxies. Imagine them as grand, bustling cities in this cosmic web, places where tens of thousands of galaxies are drawn together by their shared gravity. They glow with a fierce, ancient light, dense knots of matter and energy, the very heart of creation in this vast design. You can almost feel the gravitational pull from here, a gentle, insistent hum that has been gathering this light together for billions of years. These clusters are the bright, shining jewels sewn into the fabric of the cosmos. But as you gaze upon this stunning web of light, your eyes are drawn to something else. Something just as vast and just as fundamental to the design. The spaces between the threads. The great, dark, empty patches in the tapestry. These are not small gaps. They are immense, spherical, and amorphous regions of profound emptiness. Oceans of silence, they are the cosmic voids. If the filaments are the rivers of the universe, the voids are the great, still lakes. If the clusters are the bright cities, the voids are the sprawling, quiet countryside. They are the parts of the tapestry where the weaver's thread is absent, where the design calls for darkness and peace. They dominate the landscape of the universe. In fact, most of the universe is not in the bright filaments or the dense clusters. Most of the universe is the voids. They make up the vast majority of its volume, great bubbles of near-nothingness that swell and press against the shining walls of galaxies. Look at them now in your mind's eye. See how the filaments of light seem to define their edges like the shores of a dark, cosmic sea. There is a breathtaking beauty in this contrast. The light needs the darkness to be seen. The structure needs the emptiness to have form. The sound needs the silence to be heard. The two are in a cosmic dance, a perfect balance of something and nothing, of presence and absence. This is the grand structure of our universe. Not a uniform soup of stars, but this incredible, cellular, web-like pattern. A cosmic foam of light and shadow. And as you float here, an observer of this totality, a gentle question may begin to form in your mind. A question that has puzzled and inspired astronomers for decades. Why? Why this shape? Why is the universe not a smooth, even distribution of matter? What great force, what ancient process acted as the cosmic weaver to create this tapestry? What sculpted these immense valleys of nothingness and piled the galaxies into shimmering walls and rivers? Why are there these vast, empty spaces between the galaxies? It is a question that takes us back to the very beginning of time, to the fundamental forces that govern all of existence. It is a story of gravity, the patient sculptor, and of a mysterious, unseen substance that provides the skeleton for this grand design. It is a tale of whispers from the dawn of the universe, tiny ripples in the fabric of space-time that would, over eons, grow into the magnificent structure you see before you. For now, simply rest in this image. The glowing web, the deep, quiet voids. Feel the perfect, serene balance of it all. This is our universe, in all its strange and wondrous glory. A place not just of light, but of profound and beautiful emptiness. The stage is set. The mystery is before us. And we have all the time in the world to explore it, gently, peacefully, as we drift together into the quiet heart of the cosmic night. Section 2. Charting the Great Nothing. And so you float, suspended in the quiet of your mind, gazing upon this cosmic tapestry. The question hangs softly in the air, a gentle echo. Why? Why this magnificent web-like form? It is a profound question, one that touches the very soul of the cosmos. But before we seek the answer to why, we must first honor the incredible journey of how we came to know the question at all. Before the architects come the map makers. How did we, on our small blue world, ever manage to draw a map of such an impossible scale? How do you chart a territory whose most prominent features are defined by their very absence? How do you map the nothingness? It is a beautiful paradox. You cannot see the void itself. You cannot point a telescope at emptiness and say, "There, I have found it." Instead, the story of discovering the voids is the story of patiently, meticulously charting everything else. It is a story of cosmic cartography undertaken by generations of astronomers who, like the explorers of old, sought to map the true shape of their world. But their ocean was the universe, their ships were observatories, and their compass was the light from distant galaxies. Imagine one of these cosmic cartographers. They sit not on a high-sea cliff, but in the quiet, cool dome of a telescope. They are not mapping a coastline, but a tiny, dark patch of the night sky, a window that appears utterly black to the naked eye. Through their powerful instrument, this patch of blackness resolves into a faint dusting of smudges. These are the galaxies, the lighthouses of the cosmic ocean. To make their map, they need to know two things for each smudge of light: where it is in the sky and how far away it is. The where is the easy part. It is a set of coordinates, like latitude and longitude on a celestial sphere. But how far, that is the secret that unlocked the universe's third dimension. The key to the secret is hidden in the very nature of light itself. Think of the sound of a distant siren. As it races towards you, the sound waves are compressed, and the pitch is high. As it moves away, the sound waves are stretched, and the pitch drops lower. It's a familiar, mournful change in tone. Now, imagine this same principle applied not to sound, but to light. Light, too, travels in waves. When a galaxy is moving towards us, its light waves are compressed, shifting them towards the blue end of the spectrum. But almost every distant galaxy is moving away from us, carried on the expanding current of space-time itself. Imagine the universe is a loaf of raisin bread rising in an oven. Every raisin is a galaxy. From the perspective of any single raisin, all the other raisins are moving away from it as the dough expands. The further away a raisin is, the faster it appears to be receding. Our universe is just like this. And as these galaxies rush away from us, the light they emit is stretched. The waves become longer, lower in frequency. They are shifted towards the red end of the spectrum. This phenomenon, this gentle stretching of starlight over cosmic distances, is called redshift. The amount of redshift is a direct message from the galaxy, a whisper across the eons that tells us how fast it is receding. And because its speed is related to its distance, this redshift becomes our cosmic measuring tape. A faint galaxy with a small redshift is a relatively close neighbor. A faint galaxy with a massive redshift is a weary traveler from the farthest shores of the known universe, its light having journeyed for billions of years, stretched and reddened by the long journey through expanding space. So our cosmic cartographer begins their patient work. They point the telescope at a single faint galaxy. They let its ancient light trickle in for hours, sometimes for nights on end. They capture its spectrum, a rainbow barcode of its elemental makeup. And within that barcode, they find the telltale shift towards red. They perform their calculations and a number emerges. The distance. They have placed the first pin on their three-dimensional map. Now imagine the sheer, quiet dedication this requires. You must repeat this process. Not once, not 100 times, but thousands and then hundreds of thousands and now millions of times. Galaxy by galaxy. Pin by pin. A project of decades. It is like creating a vast Pointillism painting of the universe using single galaxies as your dots of paint. At first, the canvas looks random, a scattering of points in a dark, cubic space within a computer's memory. There is no discernible pattern. But as the mapmakers continue their work, as more and more data points are added, something extraordinary begins to happen. The random scattering of points starts to resolve. It is the same feeling as watching a photograph slowly develop in a darkroom. Out of the noise, a structure emerges. The pins are not random. They begin to line up. They form long, delicate chains. They gather in dense, bright knots. The filaments and superclusters of the cosmic web reveal themselves, dot by dot by dot. And as these luminous structures take shape, the voids appear. They are not drawn, but revealed. They are the great, dark volumes where the pins are not. The cartographers never set out to map emptiness. They set out to map everything. And in the process, the emptiness defined itself like a coastline emerging from the sea as you place markers for every single grain of sand on the beach. The voids are the ghost-like shapes, the quiet spaces that give the everything its form. In your mind, picture this map. It is no longer a flat image, but a glowing, three-dimensional model that you can hold in your awareness. You can turn it. You can fly through it. You see the great walls of galaxies, like shimmering curtains. You see the long, winding filaments, the bright highways of the cosmos. And you see them for what they are, the boundaries of something else. They are the shores of immense, dark, quiet oceans. You can now peer into the Boötes void or the Great Northern Void. You can appreciate their scale, their roundness, their profound emptiness, because you can see the brilliant, shining walls that contain them. This is how we know. not through a single dramatic discovery, but through the slow, patient, and collaborative accumulation of light. A quiet, collective act of listening to the whispers of the cosmos. We have drawn the map. We have charted the great nothing. We have seen the grand design in all its breathtaking detail. And now, holding this map in our minds, the question of why returns, no longer a simple query, but a deep, resonant hum of curiosity. Now that we know the shape of our universe, we can begin to ask how it was sculpted. Our journey must now take us backward in time, to before the galaxies, before the stars, to the very first light, in search of the ancient seeds of this beautiful empty silence. Section 3. Whispers from the Beginning. To understand the great, silent voids, we must take a journey, not through space, but through time. Let your awareness, which has been floating so peacefully amongst the galaxies, now begin to drift backwards, past the formation of our own sun and earth, past the birth of the very first stars, their violent, brilliant light yet to ignite. Further and further back we drift through a time when the universe was a dark, starless expanse of cooling gas. We are traveling towards the very dawn of time, to an era so ancient it borders on imagination. Our destination is the moment the universe first became transparent, the moment light was finally set free. Let us settle here, at this ancient shoreline of time, about 380,000 years after the Big Bang. Before this moment, the universe was an impossible place. A hot, dense, opaque fog. Imagine a light bulb inside a cloud of steam so thick that the light cannot escape. This was the early universe. It was a searing plasma of protons, electrons, and photons, particles of light. In this chaotic soup, the photons were trapped. They would no sooner begin a journey than they would collide with a free-roaming electron, be absorbed, and sent careening off in a different direction. Light could not travel. The universe was blind. But as we float here, at the edge of this era, the universe is cooling. It has been expanding ever since its first moment, and with that expansion comes a soothing, gradual drop in temperature. It is about to reach a magical threshold, a tipping point. The temperature is about to cool enough for the protons and electrons, which had been zipping around frantically, to finally find each other. To slow down enough to be captured by the gentle embrace of the electromagnetic force. They begin to combine, forming the first neutral atoms of hydrogen and helium. Think of it as a cosmic settling, a great universal calm descending upon the chaos. The fog is clearing. The steam is condensing into water droplets. The electrons that once scattered light at every turn are now safely bound within atoms. And because of this, for the very first time, the photons of light are free. The universe, in a single, silent, magnificent moment, becomes transparent. The light that was freed in that instant has been traveling ever since. It is the oldest light in the universe. It has been journeying across the cosmos for 13.8 billion years. A faint, ghostly echo of creation's first cry. It washes over everything. It is passing through you right now. We cannot see it with our eyes, because the relentless expansion of the universe has stretched its light waves, just like the light from distant galaxies. It is no longer brilliant, visible light. It has been stretched so far that it is now in the microwave part of the spectrum. This ancient, tired light is called the cosmic microwave background, or the CMB. Imagine you could tune a radio not to a music station, but to the frequency of this ancient light. You would hear a soft, gentle hiss, a static that fills the entire sky, coming from every direction with almost perfect uniformity. It is the sound of the universe's own baby picture, the afterglow of the Big Bang. For a long time, we believed this light was perfectly smooth, that the temperature of this ancient glow was exactly the same everywhere we looked. If it were, our universe today would be a smooth, uniform soup with no galaxies, no clusters, and no voids. A cosmos without structure, without form. But our instruments became more and more sensitive, capable of detecting the most delicate changes. And as we looked closer at this baby picture of the universe, we found them. tiny, almost imperceptible variations. We found spots on the map of the cosmic microwave background that were ever so slightly hotter and other spots that were ever so slightly colder. The differences are minuscule, a change of just 1 part in 100,000. Imagine a perfectly smooth ocean, and on its surface are ripples no taller than a single grain of sand. These are the variations in the CMB. And in these tiny, ancient ripples, you are seeing the very seeds of everything. The blueprint for the entire cosmic web. Let your mind float over this map of the early universe. See the subtle patchwork of slightly warmer and slightly cooler regions. The reddish spots represent areas that were infinitesimally denser and hotter than average. The bluish spots represent areas that were infinitesimally less dense and slightly cooler. They seem random, like the pattern on a stone. But these are the whispers of destiny. The very first hints of structure imprinted on the fabric of space-time itself in the first fractions of a second of the universe's existence. These warmer, denser regions are the primordial seeds of this something. They are the places where matter had a tiny, almost negligible head start. They are the locations of future greatness, the places where gravity would have just a little more to work with. Over the vast expanse of cosmic time, these are the regions that will grow into the filaments of galaxies, the places that will blossom into the great shining superclusters. They are the ink blots from which the glowing threads of the tapestry will be drawn. And the other places? The slightly cooler, less dense regions? These are the seeds of the nothing. These are the places that, by pure chance, started out with just a little less matter. They were just a tiny bit more sparse than their surroundings. In the grand cosmic lottery, they were born with a slight deficit. And over the eons, this tiny initial difference would be magnified into an outcome of epic proportions. These are the birthplaces of the great cosmic voids. They are the quiet, empty spaces in the blueprint, the negative image of the structure that is to come. As you look at this ancient light, you are witnessing the very beginning of the cosmic divide. The universe is not yet a web of light and dark. It is still a nearly uniform guess. But the instructions have been written. The path has been set. The tiny variations you see are the faint, high-altitude sources of 2 mighty rivers. One river, born from the denser regions, will gather matter and light into itself, becoming a mighty torrent of creation. The other river, born from the less dense regions, will see what little matter it has flow away from it, its banks widening until it becomes a vast, still ocean of emptiness. So the answer to our question, why are there voids, begins here. It begins with quantum fluctuations in the first moments of time, stretched to astronomical scales by a period of rapid inflation. It begins with these tiny, random, beautiful imperfections in the otherwise smooth fabric of the newborn cosmos. They were the first notes in a symphony that would take billions of years to play out. They are the gentle whispers from the beginning that would, in time, be amplified by the patient, relentless work of gravity, to become the thundering silence of the great cosmic voids. Section 4. Gravity, the patient cosmic sculptor. We linger here at the dawn of the transparent universe with the blueprint of the cosmos laid out before us in the faint glow of the cosmic microwave background. We have seen the seeds of structure, the tiny regions of slightly higher and lower density. But a seed is only a promise. A blueprint is only a plan. Something must take this faint potential and turn it into the magnificent reality you witnessed earlier, the grand cosmic web. That something, that artist, that patient and relentless cosmic sculptor is gravity. Let your consciousness now begin to drift forward in time, away from the ancient glow of the CMB. The universe is still dark. There are no stars yet, only vast, silent clouds of hydrogen and helium gas drifting in the expanding darkness. But gravity is already at work. It is a force of infinite patience and unwavering purpose. It is the architect of the cosmos, and its one simple rule is matter attracts matter. Focus your mind's eye on one of those slightly denser regions from the ancient blueprint. A place where, by pure chance, there is just a little more matter than average. Imagine it as a subtle thickening in the cosmic gas. Gravity, in its quiet way, begins to act. The particles in this region exert a gentle pull on each other. The region's own gravity also exerts a pull on the gas surrounding it. The effect is infinitesimal at first, a whisper of a pull easily lost in the overall expansion of the universe that is trying to pull everything apart. It is a cosmic tug-of-war. The outward push of universal expansion versus the inward pull of local gravity. In the very beginning, for millions of years, expansion is winning. The universe is growing so fast that even these denser regions continue to expand. But they expand just a little more slowly than the regions around them. The brakes are being gently applied. While the rest of the universe is a speeding train, these denser regions are a car with its foot lightly on the pedal. They are still moving forward, but their destiny has changed. Now let us turn our attention to one of the other regions. One of the cooler, slightly less dense spots in the CMB. A place destined to become a void. Here, the situation is reversed. There is slightly less matter, which means there is slightly less gravitational pull to counteract the universe's expansion. In the great cosmic tug-of-war, expansion has an even greater advantage here. The gas in these regions expands even faster than the cosmic average. It is being stretched thin, its precious matter pulled away towards the more gravitationally attractive regions nearby. See this process unfolding in your mind. It is a slow, graceful, and epic sorting of the cosmos. Imagine a vast, smooth field of sand. Now imagine a few areas on this field are imperceptibly thicker. Over time, gentle winds begin to blow the sand from the thinner areas and deposit it onto the thicker ones. The thicker patches grow, becoming small hills. The thinner patches are scoured away, becoming shallow valleys. Over eons, the hills grow into mountains and the valleys deepen into vast basins. This is precisely what gravity is doing to the gas of the early universe. The rich get richer and the poor get poorer. The denser regions, with their slight gravitational advantage, continue to pull in more and more material from their surroundings. They are gravitational basins, and matter, like water, flows downhill. Over hundreds of millions of years, these regions stop expanding altogether. They decouple from the universal expansion, and for the first time, gravity wins the tug-of-war. The inward pull becomes dominant. These vast clouds of gas begin to collapse under their own weight. As they collapse, they become hotter and denser. Pockets within them reach a critical point, a crucible of pressure and heat where the very first stars ignite, bursting forth in a brilliant blaze of light, ending the cosmic dark ages. These first stars are born along the lines and at the intersections of these collapsing structures. They form the first galaxies. The filaments of the cosmic web are beginning to glow. The gas flows along these filaments like rivers of fuel, feeding the nascent galaxies that cluster at the intersections, the places that will become the great galactic cities. Gravity is the sculptor, and it is carving its masterpiece with slow, deliberate, and powerful strokes. But what of the voids? As the filaments and clusters grow, they do so at the expense of the regions in between. They are gravitational thieves, siphoning all the available matter from their surroundings. The regions that started out with a slight deficit of matter now find themselves being actively emptied. Their gas flows outwards, downhill, towards the gravitational mountains rising on their borders. The process is self-reinforcing. The less matter a region has, the weaker its gravity becomes. The weaker its gravity, the more easily its remaining matter is stolen away by its neighbors. The voids are not pushed empty. They are pulled empty. Imagine a vast, dark ballroom. The dancers, representing particles of matter, are initially spread out fairly evenly. But a few popular dancers begin to form small, charismatic groups. These groups attract more and more dancers from the surrounding floor. As the groups swell into large, vibrant clusters, the spaces between them become more and more empty. The dancers have evacuated the floor to join the groups. The voids are simply the parts of the dance floor that everyone has left. This process continues for billions of years. Gravity, the patient sculptor, never rests. It continues to pile matter onto the filaments. It continues to draw galaxies into ever larger clusters. And in doing so, It continues to sharpen the edges of the voids, to deepen their emptiness, to scour them clean of almost all material. The faint, subtle variations we saw in the cosmic microwave background have been amplified by gravity over 13 billion years. The tiny hills have become towering mountain ranges of light, and the shallow valleys have been carved into the immense, profound canyons of darkness we call the cosmic voids. There is a profound, almost philosophical beauty in this process. Gravity, the force that brings things together, is the very reason the universe is so empty. Its relentless gathering in one place necessitates an equally relentless emptying in another. The existence of the shining, matter-filled filaments is inextricably linked to the existence of the dark, silent voids. They are two sides of the same cosmic coin, sculpted into being by the same universal artist. One cannot exist without the other. They are the yin and yang of cosmic structure, a perfect, balanced testament to the patient, creative power of the universe's master sculptor, gravity. Section 5. The unseen skeleton of dark matter. We have credited gravity as the patient sculptor of the cosmos, the artist that carved the voids and raised the filaments. And that is true. But we have only told half of the story. The gas clouds of hydrogen and helium that we have been watching are merely the paint. Gravity is the brush. But for a structure so vast and intricate as the cosmic web, there must be a frame, a scaffold, an unseen skeleton upon which the paint is applied. Without this hidden structure, the masterpiece could never have taken form. This invisible skeleton is one of the deepest and most profound mysteries in all of science. We call it dark matter. Let us return to our view of the early universe just after the first light was set free. We see the vast clouds of ordinary matter, the protons and electrons that have combined to form hydrogen and helium atoms. We see the slight density variations, the seeds of all future structure. And we see gravity begin its patient work, slowly pulling the denser regions together. But there is a problem. There is a cosmic dilemma. The force of gravity from this ordinary matter alone is not enough. It is too weak. The outward pressure from the hot gas and the fierce radiation of the early universe is fighting back. If ordinary matter were all that existed, its gravity would have struggled to overcome this outward push. The process of structure formation would have been incredibly slow, almost agonizingly so. There must be something else. Something we cannot see. A source of immense, additional gravity that has been shaping the cosmos from the shadows since the very beginning. This is dark matter. Imagine that alongside every particle of ordinary matter, every proton, every neutron, every electron, there exists a different kind of particle. A particle that is quiet, aloof, and reclusive. It does not shine. It does not reflect light. It does not absorb light. It does not interact with the electromagnetic force at all. It is, for all intents and purposes, invisible. Light passes right through it as if it weren't there. If you were holding a clump of it in your hand, you wouldn't see it, you wouldn't feel it, and your hand would pass right through it. But it has one crucial property. It has mass. And because it has mass, it has gravity. And there is not just a little of it. There is an enormous amount. For every 1 kilogram of the stuff that makes up you, the stars, the planets, and the gas clouds, the ordinary matter, the universe contains more than 5 kilograms of this strange, invisible dark matter. It is the true majority shareholder of matter in the cosmos. We are the afterthought, the decorative frosting on a much larger, darker cake. Now let us replay the formation of the cosmic web, but this time with dark matter included in the story. In the early universe, it too was distributed with those same tiny density variations. But dark matter has a secret advantage. Because it does not interact with light or radiation, it doesn't feel the same outward pressure that was holding back the ordinary matter. It is immune to the fight. So, while the ordinary gas was struggling to collapse, the dark matter was not. Imagine dark matter as a collection of heavy, invisible stones at the bottom of a river and ordinary matter as fine sand suspended in the water. The current of the river, the expansion and pressure of the early universe can easily keep the sand from settling. But the heavy stones are unaffected. They can begin to clump together, drawn by their own gravity long before the sand can. This is what happened in the cosmos. The dark matter, freed from the pressure of radiation, began to collapse into structures much, much earlier than the ordinary matter. It began to form vast, invisible concentrations of mass known as dark matter halos. It created a network of unseen filaments, a gravitational skeleton that mirrored the initial blueprint in the CMB. It built the scaffolding first. It dug the gravitational riverbeds. These deep, invisible pools of gravity, these dark matter halos, then became the targets for the ordinary matter. The ordinary, visible gas, once it finally cooled enough to overcome its own pressure, was drawn irresistibly towards these pre-existing structures. It was like sand finally settling into the deep impressions the heavy stones had already made at the bottom of the river. The ordinary matter simply fell into the cosmic web that dark matter had already built. So when you see a great supercluster of galaxies, what you are really seeing is the visible glow of galaxies that have collected at the bottom of a truly colossal well of dark matter. The light is just a beacon signaling the presence of a much larger, much more massive, unseen structure. The shining filaments of galaxies that trace the cosmic web are like strings of Christmas lights draped over a vast, invisible tree. The tree itself, the dark matter, is the true structure. The lights just show us its shape. And this changes our understanding of the voids. The voids exist because they are the regions where there was very little dark matter to begin with. They were the places on the blueprint that were destined to have less of everything. Because there was no deep gravitational well of dark matter to fall into, the ordinary matter never collected there. In fact, the faint gravitational pull of the surrounding dark matter halos actively helped to pull what little gas there was out of the void regions. The voids are empty of light because they are, first and foremost, empty of darkness. As you float here, contemplating this unseen reality, feel the shift in your perception of the universe. The cosmos, you see the brilliant stars, the majestic galaxies, is just the visible foam on a much deeper, unseen ocean. The true architecture of the universe is invisible. It is a silent, ghostly structure of dark matter that dictates where the light can and cannot go. The voids are the great, cavernous gaps in this dark matter skeleton, places where the scaffolding was never built. The existence of dark matter is not a wild guess. We see its gravitational effects everywhere. We see galaxies rotating so fast they should fly apart, but they are held together by the gravity of an unseen halo. We see light from distant galaxies being bent and distorted as it passes by massive clusters, a phenomenon called gravitational lensing, revealing a mass that is far greater than what we can see. The evidence is abundant and clear. The universe is being shaped by a substance we cannot see and do not yet understand. It is a humbling and awe-inspiring thought. A quiet reminder that what we see is only a sliver of the whole story, and that the greatest secrets of the cosmos may still be hiding in the dark. Section 6. Dark Energy's Gentle, Constant Push. We have assembled the key players in our cosmic drama. We have the blueprint from the cosmic microwave background, the seeds of something and nothing. We have the patient sculptor, gravity, which amplifies these seeds. And we have the invisible skeleton, dark matter, which provides the framework for gravity to work upon. Together, they have woven the magnificent cosmic web. For billions of years, this has been the primary story of the universe, the story of gravity pulling matter together. It would be natural to assume that this process would continue forever, that the filaments would grow thicker, the clusters more massive, and the voids, while large, would remain defined by the inexorable pull of matter. But about 5 billion years ago, a new character took center stage in the cosmos. A force that had been present all along, but hiding in the background, biding its time. As the universe continued to expand, as the galaxies and clusters grew further and further apart, the grip of gravity over vast cosmic distances began to weaken. Imagine two magnets. When they are close, their attraction is strong, but as you pull them apart, their influence on each other fades rapidly. Gravity acts in much the same way. As the universe expanded, the density of matter decreased, and gravity's ability to pull everything back together on the largest scales began to wane. And into this weakening, a new force, a gentle, persistent, and utterly mysterious influence began to dominate. We call it dark energy. Unlike dark matter, which clumps together and pulls things in, dark energy is smooth, uniform, and repulsive. It is not a substance, but rather a property of space itself. It seems to be an intrinsic energy woven into the very fabric of the vacuum. Imagine that empty space is not truly empty. Imagine it has a latent energy, a quiet, constant pressure that wants to expand. For the first 9 billion years of the universe's history, the inward pull of gravity from all the matter and dark matter was stronger than this gentle outward push. The universe was expanding, yes, but that expansion was slowing down. Everyone expected that it would continue to slow, perhaps even one day stopping and collapsing back in on itself in a big crunch. But then the tipping point was reached. The universe had become so large, and the matter within it so spread out, that the collective pull of gravity became weaker than the constant, gentle push of dark energy. And at that moment, the expansion of the universe stopped slowing down. It began to accelerate. Feel this shift in the rhythm of the cosmos. The universe took a deep, cosmic breath and began to expand faster and faster. This acceleration is not a violent explosion. It is a slow, steady, and relentless process. It is like a gentle, constant wind that is always blowing, pushing the galaxies further and further apart. And what does this cosmic acceleration mean for our beautiful, empty voids? It means they are growing. Think back to our image of the voids as great, empty bubbles in a cosmic foam. The filaments and clusters of galaxies are the shining walls of these bubbles. Dark energy is now acting like an internal pressure inside each of these bubbles, causing them to swell. The less matter a region contains, the more dominant the effect of dark energy becomes. Since the voids are, by definition, the emptiest places in the universe, they are the regions where dark energy has the most profound effect. So while gravity is still the master within the filaments and clusters, pulling galaxies together into tighter and tighter groups, dark energy is the master of the voids. It is taking the vast emptiness sculpted by gravity and dark matter, and it is stretching it. The voids are getting bigger, pushing the walls of the cosmic web further and further apart. They are actively driving the accelerated expansion of the universe. In your mind's eye, see this process in motion. See the great filaments of galaxies like shining chains. Feel the inward pull of gravity holding these chains together. Now feel a gentle, irresistible pressure from within the dark spaces, pushing these chains away from each other. The voids are swelling like balloons, their dark, silent volumes increasing with every passing moment. The beautiful, delicate balance of the cosmic web is changing. The darkness is beginning to win over the light. This introduces a new and perhaps slightly melancholic element to our story. The work of gravity, the patient sculptor, is being undone on the grandest scales. The superclusters, the great cities of the universe, are becoming increasingly isolated. Galaxies in distant clusters are now receding from us so fast that their light will one day never be able to reach us. They will cross the cosmic horizon and disappear from our view forever, their redshift becoming infinite. The universe, in its far future, is destined to become a much lonelier place. The magnificent, interconnected web will be stretched so thin that our own local group of galaxies will appear as a single, isolated island of light in a vast, unending ocean of dark, empty, accelerating space. The voids, powered by dark energy, will have consumed the cosmos. There is a profound philosophical weight to this. The very emptiness that defines the beauty of the cosmic web is also the engine of its eventual dissolution. The voids are not just passive gaps. They are active participants in the universe's evolution. They are the places where the fundamental nature of space itself is revealed, a space that is not static but dynamic and filled with a mysterious, repulsive energy. So, the answer to why are there large empty spaces between galaxies has become layered and deep. They exist because of tiny quantum fluctuations at the dawn of time. They were carved out by the gravitational pull of an invisible dark matter skeleton. And now they are being expanded and enlarged by the mysterious, constant push of dark energy. They are the past, present, and future of the universe's structure, all contained within their silent, beautiful emptiness. As we float here, we are left with a sense of awe, not just for what we know, but for what we do not. What is dark energy? Is it a constant, or does it change with time? Its discovery was a complete surprise, a Nobel Prize-winning revelation that turned our understanding of the universe on its head. It is, along with dark matter, a stark and humbling reminder that our visible universe is only a tiny fraction of reality. The great cosmic voids are not just empty, they are filled with the presence of our own profound ignorance, a quiet space that beckons us to keep questioning, keep wondering, and keep exploring the deep, dark, and beautiful mysteries of the night. Section 7. A Journey into a Void. We have spent our time as celestial observers watching the grand cosmic dance from a safe and distant vantage point. We have seen the blueprint, watched the sculptor, and felt the gentle, mysterious push that expands the voids. But now let us do something different. Let us become travelers. Let your awareness, which has been floating in the space between, now choose a destination. See the beautiful, glowing walls of a filament, a river of light. And next to it, a great, dark, spherical region of emptiness. Let us turn our attention towards this void and gently, slowly begin to drift inside. As we cross the boundary, the change is not sudden. It is a slow, graceful fading. The river of galaxies behind us does not simply switch off. It recedes. The bright, bustling cities of the supercluster become distant towns, then tiny villages, then faint, lonely specks of light in our cosmic rearview mirror. The density of galaxies drops precipitously. Inside the filament, you were never far from a neighbor. Here, inside the void, the concept of neighbor loses its meaning. Drift deeper into the heart of this immense emptiness. The light from the surrounding cosmic web has now faded into a soft, uniform, distant glow in every direction. It is like being in the center of a colossal, spherical room where the walls are made of faint, shimmering starlight. There is no up or down, no right or left. There is only the center where you are and the distant, shimmering edge. What is it like here? The first thing you feel is the silence. A silence so profound it is almost a presence. The humming, crackling energy of the dense clusters is gone. The gravitational chatter of a billion galaxies is gone. Here, there is only the quiet, fundamental hiss of the cosmic microwave background. The oldest sound in the universe, a lullaby from the dawn of time. The silence is not menacing. It is peaceful. It is the sound of space-time itself, resting. The darkness, too, is different. It is not the crowded, busy darkness you find within a galaxy, where nebulae and dust obscure the stars behind them. This is a clean, pure, transparent darkness. Perfect black. The few points of light you can see are not the close, bright stars of a single galaxy. They are other, entire galaxies, but they are so far away, so incredibly isolated, that they appear as tiny, lonely pinpricks. Here, a single galaxy might be the only one for millions of light-years in any direction. Let us imagine we find one. A void galaxy. They are rare, but they exist. Lost children of the cosmos who somehow managed to form in this great emptiness, or perhaps were flung out of a filament in some ancient gravitational encounter. This galaxy would be a lonely place. Its night sky would be breathtakingly different from our own. From a planet within this galaxy, you would look up and see the brilliant stars of your own home galaxy, a familiar river of light. But beyond that, almost nothing. The sky would be a deep, profound, velvet black, punctuated by only the faintest, most distant smudges of other galaxies. To the inhabitants of such a world, the universe might truly seem to be just their own island, surrounded by an infinite and almost absolute emptiness. The grand, web-like structure of the cosmos would be completely invisible to them, a secret hidden by immense distance and solitude. As you float here, in this vastness, A sense of scale washes over you. These voids are not small. A typical void is 100 million light-years across. The largest, like the one we will visit soon, are many times that size. Light, the fastest thing in the universe, would take 100 million years to cross from one side to the other. Our entire Milky Way galaxy, with its hundreds of billions of stars, would be like a single grain of sand lost in a vast empty stadium. All of human history, from the first tools to this very moment, is a fleeting spark in the time it would take to traverse this space. To be here is to be humbled by scale. And yet it is not truly empty. The word void is a slight misnomer. It is not a perfect vacuum. Even here, in the heart of the great nothing, there is still something. There would be, on average, perhaps less than 1 atom per cubic meter. Compare that to the space between stars in our own galaxy, which is 1,000,000 times denser. Compare it to the air you are breathing, which is 1 billion times denser. So yes, it is astonishingly empty, the best vacuum that nature has ever produced. But it is not nothing. Drifting through this space, you would occasionally encounter a stray hydrogen atom, a lonely particle on a journey of its own. And what about dark matter? Even here, there is some. It, too, is incredibly sparse. A faint, ghostly mist of particles that provides a tiny, almost negligible amount of gravity. And of course, there is dark energy. Here, in the emptiness, you can feel it most keenly. It is not a wind or a pressure you can touch, but a sense of slow, inexorable expansion. It is the feeling of space itself quietly and gently pushing outwards, making the void even larger, pushing the distant walls of light even further away. Here, you are in the engine room of cosmic acceleration. There is a unique kind of beauty here, a minimalist, contemplative beauty. It is the beauty of absence, of potential, of peace. In the bustling filaments, the universe is a place of being. Here in the void, it is a place of becoming. It is a canvas waiting for a brush that may never come. It is a stage for a play that has not been written. To exist in a void would be to understand loneliness in its most profound cosmic sense. But it would also be to understand tranquility. It is a place free from the chaos and violence of galactic collisions and supernovae. A place of deep, deep peace. A place to simply be, to float, to contemplate the distant lights, and to feel the slow, steady pulse of an expanding universe. It is a reminder that the universe's character is not just defined by its dazzling concentrations of matter and energy, but also by its vast, serene, and majestic expanses of quiet and solitude. It is the space that gives the music its meaning, the silence between the notes of the cosmic symphony. Section 8. The Boötes Void, an ocean of emptiness. Among the great voids that pockmark the cosmic landscape, there is one that holds a special place in the human imagination. It is a giant among giants, a region of emptiness so vast and so profound that its discovery challenged our very assumptions about the universe. It is known in a name that is both simple and deeply evocative as the Boötes Void. Some call it the Great Nothing. Let us now turn our attention to this specific, famous place. We will not just drift into its edge, we will attempt to comprehend its scale, to feel the weight of its magnificent emptiness. Our journey begins by locating it on our cosmic map. It lies in the direction of the constellation Boötes, the herdsman, a familiar pattern of stars in our northern sky. But of course, the void is not in the constellation. The stars of Boötes are our galactic neighbors, a mere few hundred light-years away in our own backyard. The void lies far beyond them, a monstrous, dark presence lurking in the deep space behind those familiar stellar patterns. Its center is roughly 700 million light-years from Earth. To reach it, you would have to travel past thousands of other galaxies, across the Laniakea supercluster that we call home, and out into the wider cosmic web. As we approach it, we begin to realize this is no ordinary void. The region of sparse galaxies is wider, the fall-off into nothingness more dramatic. When astronomers first began to map this region of the sky in the late 1970s and early 80s, they expected to find galaxies as they did everywhere else they looked. But their surveys kept coming back empty. They would probe deeper and deeper, expecting to hit a wall of galaxies, the far side of a normal-sized void. But they just kept finding more and more nothing. It was as if someone had taken a giant cosmic ice cream scoop and hollowed out a colossal sphere from the universe. Let us now float at its edge and try to grasp its size. The Boötes void is nearly 330 million light-years in diameter. Let that number settle in your mind. 330 million light-years. If our Milky Way galaxy, a majestic spiral of 400 billion stars, were placed at the very center of the Boötes void, we would not be able to see the edge. From Earth, our most powerful telescopes would not be able to detect the shimmering walls of galaxies that define its boundary. The night sky, even for our best instruments, would be almost completely and utterly dark. The story of the universe being a grand web of galaxies would be a theory, a myth, something that could be mathematically predicted but never directly observed. We would be truly, profoundly alone. Let's try another way to feel the scale. Imagine you are in a spaceship that can travel at the speed of light. An impossible speed, but let's imagine. You decide to cross the Milky Way from one edge to the other. It would take you 100,000 years. A vast journey. Now, from the edge of the Milky Way, you set your sights on our nearest major galactic neighbor, Andromeda. That journey would take you 2.5 million years. Now, imagine you are at one edge of the Boötes void and you want to cross to the other side. That journey, at the speed of light, would take you 330 million years. You could cross our galaxy 3,300 times in the time it would take you to make this one single journey across this one single patch of emptiness. It is an ocean of silence, and we are not just talking about a pond. When it was first discovered, the sheer scale of the Boötes void was a problem. A big one. Our models of cosmic formation, the ones we have so peacefully explored involving gravity and dark matter, could create voids. But they struggle to create voids this big. The slow, patient process of gravity pulling matter away should not have been able to create such a colossal sphere of emptiness in the time the universe has had to exist. It would be like a small river carving the Grand Canyon in a single afternoon. It seemed for a time to defy our understanding. The solution to the puzzle, as is often the case in cosmology, is both subtle and beautiful. The Boötes void is not actually a single, monolithic void. Later, more sensitive surveys have revealed a more complex picture. Think of it not as one giant bubble in the cosmic foam, but as a place where many smaller bubbles have merged. Imagine blowing soap bubbles. If two bubbles drift into each other, their shared wall can dissolve, and they merge to become one larger, elongated bubble. It is now thought that the Boötes void is a coalescence of several smaller, more normal-sized voids which grew and merged over cosmic time. We can even see faint, ghostly filaments of a few galaxies meandering through its volume, like the faint, ghostly remnants of the walls of those original, smaller bubbles. These are the last vestiges of the structures that were consumed as this great nothing grew. Let's venture inside. The experience is similar to our journey into a generic void, but amplified to an almost overwhelming degree. The silence is deeper. The darkness is more complete. The sense of isolation is absolute. When its emptiness was first being quantified, it was predicted that based on its volume, it should contain roughly 10,000 galaxies. At the time of this prediction, astronomers had only found 8. A few years later, the number had risen to 60. Even if there are more, fainter ones, it remains the most underdense region of space we have ever discovered. It is a desert on a cosmic scale, the Sahara of the heavens. To float in the center of the Boötes void is to be in a place defined by its relationship to the rest of the universe, which is to say, its almost complete lack of one. It is a cosmic monastery, place of profound retreat. The great, chaotic, beautiful story of galactic evolution, of stars being born and dying, of matter being recycled and reformed, is happening somewhere else. It is happening far, far away. Here, time itself seems to pass differently, marked not by the ticking clock of stellar events, but by the slow, imperceptible swelling of the void itself, driven by the quiet push of dark energy. The Boötes void serves as a powerful anchor for our sense of wonder. It reminds us that the universe is not homogeneous. It is lumpy. It is filled with character and personality. It has its bustling cities, its quiet highways, its forgotten country lanes, and its vast, untamed wildernesses. The Boötes void is the grandest of these wildernesses. It is a monument to the power of gravity to separate and sort, and a testament to the immense, mind-boggling scale of reality. It is not something to be feared. It is something to be revered, a place of magnificent, beautiful, and awe-inspiring nothing. Section 9. The Void's Subtle Push and Pull. We have journeyed far into the heart of the great voids and stood in awe of their immense, silent scale. It is easy to think of them as passive, isolated features of the cosmos, great, empty spaces that simply are, while the real action happens in the glowing filaments and clusters. It is easy to imagine our own Milky Way nestled comfortably in our local group on the outskirts of the Virgo supercluster as being far removed and unaffected by these distant oceans of nothingness. But the cosmic web is a connected system. Nothing exists in true isolation. These vast regions of emptiness are not just passive spectators in the cosmic dance, they exert a subtle yet profound influence on everything, including our own journey through the universe. Imagine yourself once more floating in space, looking at the grand map of the cosmos. You see the bright, dense superclusters, and you can almost feel their immense gravitational pull. They are the great attractors, the great walls and Shapley concentrations that act as cosmic gravity wells, pulling our galaxy and all its neighbors towards them. For a long time, we thought this was the only major influence on our motion. Our Milky Way was simply falling towards the densest nearby concentration of mass. Our path through the cosmos was a journey towards something. But this is only half the story. The voids, in their own quiet way, also exert a force. It is not a pull, but a push. Now, this is not a new, mysterious force. It is still gravity, or rather, the lack thereof. Let's use a simple analogy. Imagine you are a small boat on a perfectly flat ocean. On one side of you, a massive mountain range rises out of the water. The gravity of the mountains will gently pull your boat towards the shore. This is the pull of a supercluster. But now, let's imagine that on the other side of your boat, a giant, deep trench is carved out of the ocean floor. The water that should be in that trench, which would have been pulling you equally, is now gone. The result is that you are no longer pulled equally from both sides. The absence of mass in the trench creates a net pull away from it, which feels exactly like a push. This is what the voids do. They are regions of immense underdensity, cosmic trenches carved out of the fabric of space-time. The matter that should be in them was stolen away long ago to build the filaments and clusters. So, the gravitational pull from the direction of the void is much, much weaker than the pull from the direction of a massive supercluster. The result is a net force that pushes us away from the void. Astronomers call this the void effect or a repulsive force. Our galaxy is not just being pulled by the great structures, it is also being gently but persistently pushed by the great emptinesses. Our cosmic address, it turns out, is in a very interesting neighborhood. We are being pulled by the gravity of the Virgo cluster and the larger Laniakea supercluster. But at the same time, astronomers have identified a large, nearby void, sometimes called the local void or the dipole repeller. This vast region of low density lies in the opposite direction from our main trajectory of motion. So, our journey through the universe is a combination of a pull from the front and a push from behind. Picture our Milky Way as a tiny leaf on a cosmic river. The current is flowing towards the dense gravitational structures downstream. But at the same time, the riverbank behind us is eroding away, creating a gentle slope that also encourages us to flow in that same direction. Our motion of over 600 kilometers per second relative to the cosmic microwave background is not just due to the irresistible allure of the mass ahead, but also due to the profound emptiness of the space behind us. This discovery has changed the way we think about cosmic dynamics. It adds a layer of beautiful complexity to the story. The voids are not just empty rooms in the cosmic house, they are part of the architecture that dictates the flow of traffic. Their collective push is a significant component of the velocity of every galaxy in the universe. And their influence doesn't stop there. The voids also have a subtle effect on the light that travels through them. This is a more esoteric but equally beautiful concept known as the integrated Sachs-Wolf effect. Let us go back to the cosmic microwave background, that ancient light from the dawn of time. It is traveling towards us from every direction. As a photon of this ancient light enters a supercluster, a dense region of matter, it falls into a gravity well. As it falls in, it gains energy, becoming slightly more energetic, slightly bluer. Then, as it climbs back out of the gravity well on the other side, it loses that energy again, becoming redder. If the universe were static, these two effects would cancel out perfectly and the photon would emerge with the same energy it had when it entered. But the universe is not static. It is expanding, and that expansion is accelerating, driven by dark energy. So, while the photon is traveling through the supercluster, the cluster itself is being stretched apart by cosmic expansion. The gravity well is becoming slightly shallower. This means that when the photon climbs out, it doesn't have to work as hard as it did when it fell in. It leaves with a tiny bit more energy than it started with. So, when we look at the CMB through a supercluster, we see a tiny, almost imperceptible hotspot. Now, what happens when a photon travels through a void? The opposite. A void is like an anti-gravity well, a hill instead of a valley. As the photon enters the void, it has to climb this hill, losing energy and becoming redder. While it's inside, the void is expanding and swelling due to dark energy, making the hill even taller. So when the photon comes down the other side, it doesn't gain back as much energy as it lost on the way in. It emerges slightly less energetic, slightly redder than it was before. When we look at the CMB through a great void, we see a faint, cold spot. These tiny temperature fluctuations, these hot and cold spots on the CMB map caused by the structures it passes through, are direct evidence of dark energy at work. The voids, by their very nature as expanding underdense regions, are actively imprinting their signature on the oldest light in the universe. They are leaving their fingerprints on the echo of creation. So, as you rest here, let this new understanding settle. The great empty spaces are not passive. They are dynamic. They are cosmic engines of repulsion, gently shepherding our galaxy on its long journey. They are cosmic lenses, subtly cooling the ancient light that passes through them. They are an integral, active part of the machinery of the cosmos, a quiet but powerful partner to the brilliant, shining clusters. Our existence is shaped not only by what is there, but also profoundly by what is not. Section 10. Finding Beauty in the Emptiness. Our long, quiet journey is drawing to a close. We have traveled back to the dawn of time and witnessed the planting of the first cosmic seeds. We have watched the patient hands of gravity and dark matter sculpt the universe, and felt the gentle, accelerating breath of dark energy expand it. We have ventured into the heart of the great voids, stood in awe of their scale, and understood their subtle influence on our own cosmic home. We have sought the answer to the question, why are there large, empty spaces between the galaxies? And we have found not a single, simple answer, but a beautiful layered story that touches upon the deepest principles of existence. And now, as we float here one last time, with the entire cosmic tapestry spread out in our mind's eye, let us move beyond the why and simply appreciate the is. Let us reflect on the profound, philosophical beauty of the emptiness and what it means for us. For centuries, we looked to the heavens and saw fullness. We saw a celestial sphere packed with stars, planets, and divine beings. Our stories and myths were about filling the sky, about conquering the darkness with light and meaning. The idea of emptiness, of a vacuum, was often seen as unnatural, even abhorrent. Nature, we thought, abhors a vacuum. And yet, we now know that the universe is overwhelmingly, magnificently, a vacuum. The voids are not an anomaly, they are the norm. Our matter-filled, light-drenched existence is the exception. We live on a tiny, precious crumb of something, afloat in an endless ocean of almost nothing. There is a profound humility in this realization. It reframes our perspective. The universe was not made for us. We are a beautiful, intricate, and likely rare byproduct of a set of physical laws that value both aggregation and emptiness in equal measure. The same processes that gathered the atoms to create our sun, our planet, and our bodies are the very same processes that scoured the great voids clean. The existence of here is predicated on the existence of the vast not here. Let your awareness drift to the boundary between a filament and a void. See the stark contrast. The shining, chaotic, energetic wall of galaxies and the deep, serene, silent emptiness. It is in this contrast that the true beauty of the cosmos is revealed. The light would not seem so brilliant without the profound darkness to frame it. The structure would have no form without the emptiness to define it. The cosmic music would have no rhythm without the rests between the notes. The voids are not a mistake. They are not a flaw in the design. They are a fundamental and necessary part of the composition. They are the canvas upon which the masterpiece is painted. Think of a Japanese ink wash painting, where the empty space on the paper, the ma, is as important as the brushstroke itself. It is the unpainted space that gives the painted image its power, its balance, its breath. The cosmic voids are the ma of the universe. They are the quiet spaces that allow the structure to breathe, that give it meaning and context. They teach us a lesson in cosmic aesthetics. Beauty is not always found in density and complexity, but also in simplicity, subtlety, and absence. This perspective can even echo into our own lives. We often feel a need to fill every moment with activity, every space with noise, every silence with words. We can sometimes fear the void in our own lives, the moments of quiet, of solitude, of not doing. But the universe shows us that emptiness is not something to be feared. It is the place where perspective is gained. It is the quiet that allows the faint whispers of truth to be heard. It is the space necessary for growth and contemplation. Just as the voids define the galaxies, perhaps it is the quiet moments in our lives that define our periods of activity and connection. Our journey tonight was a journey into these quiet places. We sought to understand the great empty spaces between the galaxies. In doing so, we have discovered that they are not truly empty. They are filled with the ghosts of the Big Bang in the form of the CMB. They are filled with the faint mist of dark matter. They are filled with the mysterious, accelerating power of dark energy. And most of all, they are filled with meaning. They are a testament to the history of the universe, a driver of its future, and a reflection of the elegant and often invisible laws that govern us all. They are a reminder that the universe is a place of balance. For every bright star, there is a vast darkness. For every gravitational pull, there is an expansive push. For every sound, there is a profound silence. And for every question we answer, a dozen more beautiful and awe-inspiring mysteries blossom in the quiet, empty spaces of our knowledge. The universe does not abhor a vacuum. It embraces it. It uses it. It finds its most profound beauty within it. And so, perhaps can we. As our exploration of the great cosmic voids comes to a gentle end, allow your awareness to drift back from the far reaches of the cosmos. Feel the soft weight of your body, the gentle rhythm of your breath. The universe, with its shining filaments and quiet voids, will continue its silent, magnificent dance, whether we are watching or not. Let the wonder of it all dissolve into a feeling of deep peace and tranquility. There is a place for everything in the grand design, even the emptiness. And there is a place for you right here, right now, to rest. Thank you for joining me on this peaceful journey through space and time. May your mind be calm, your thoughts be gentle, and your sleep be deep and restorative. Good night.